Let's see. You should be able to see it. Can you see it? Can you see my screen? Oh, perfect. Thank you. I got confirmation. Excellent. So let's start. We're going to talk about serving machine learning models easily with FastAPI. FastAPI is a Python web framework for building APIs with high performance. It's easy to learn, it's fast to code, and it's ready for production. So first, a little bit about myself. Who am I? I'm Sebastian Ramirez. I'm a software developer at Explosion in Berlin, Germany. You can find more about me on GitHub, LinkedIn, and Twitter. Explosion are the creators of SPACY, the natural language processing package for doing things like machine learning over text, and Prodigy, the tool for doing data annotation for machine learning using active learning, and Think, a deep learning framework using type annotations. I created FastAPI and Type. And now, actually, I'm just leaving Explosion, and I'm currently on the last days of all the accumulated vacations I had, and I'm gonna dedicate myself to work a lot more on FastAPI and Typer, like as much as I can, while also doing some limited consulting and helping other teams with their systems and their applications. So let's get to it. So a little bit about FastAPI. FastAPI currently has around 30,000 GitHub stars. It has been growing around 1,000 stars per month, so people have been liking it, which is great. This is the documentation. And FastAPI used by Microsoft, Uber, Netflix, and a bunch of other organizations. The performance that you get, it's in the top rank for Python frameworks, so that's quite nice. But now, because we are in the data science, in a data science group here, let's see, why will this be useful for you, people that are interested in machine learning and that normally do machine learning? So FastAPI for machine learning people is what we are going to see. I'm going to assume that you know machine learning. I'm not gonna explain machine learning. You probably know that perfectly. And I'm going to assume that you know the basics of web or API development, just like the very basics of how it works, like HTTP and JSON, just like the basic technologies of the web. Now let's talk a little bit about FastAPI. FastAPI is based on standards. So it's based on OpenAPI, and OpenAPI is based on JSON schema, and it also integrates with OAuth 2. These are just standards. But the thing is that because it's based on standards, it can integrate very well with other tools. So for example, we can get automatic API docs like these ones that you see on the site. So that's great. And then you get an application that is based on standards for free. So FastAPI is based on Python type hints or type annotations, which are like these ones. For example, here we are going to see an example like this one later, but quickly, we are saying that name is of type string and the price is of type float. This is the standard syntax in Python for saying that these are the types of these variables, or in here we're saying that item is of type of this class item. And because it is based on these type annotations or type hints, we get autocompletion everywhere in the code, and we get type checks and type errors right in the editor. We are going to see a little bit about that. So we get autocompletion everywhere in the code. FastAPI is easy and short, so it's very simple and easy to get used to it. This is a full FastAPI application. This is already a complete application. So we just, from FastAPI, we import the FastAPI class. We create an app, which is an instance of this class. And then we use this app to decorate some functions like this one. So we use this @ symbol, which is to make a decorator, that's the name of that. And then we declare that we are going to use an HTTP GET method or HTTP GET operation. And then we say that this is going to go to the slash or the root path in this application. And then we can just return a simple dictionary, and FastAPI will make sure to convert this to JSON and return the response correctly. And you can see that this one uses async. FastAPI is underneath an async framework. That's why it can have like all that performance and all those concurrency benefits. But the async is also optional. FastAPI can understand that if you don't use async, it will do the smart thing to make sure everything works correctly. But the thing is, it's very simple, very short, and very quick to write. So the more FastAPI code you write, the less API code you have to write, because you can now focus on the code of your application, on the business logic, on the important parts of your app. And you can let the API specific parts for FastAPI. So now let's jump to the other side, to the machine learning side. Let's say that you have a machine learning model. For this example, we're going to use FastAPI, but this could be any other library that you are using. We could instead import a TensorFlow or PyTorch or something else. In some place, you'll probably load some model from disk, like in this case, and then you will probably store it on a variable like this one. This is the model now. And then with this model, you're going to, in some way, receive some input. In this case of FastAPI, we are using this as, we are calling it directly, and we are passing the input of this text. Apple buys UK startup for 1 billion, blah, blah, blah. So this is the input to the machine learning model, in this case. And we get some result, which is this output. And then we can do something with this output. In this case, we are extracting named entities. So we are, for each one of the entities that were detected by this machine learning model, we are just printing what is the text and the label. So we detect that Apple is an organization, that UK is a geopolitical entity, so a location. And 1 billion is money. So this is the output of the machine learning model. The important part is that the machine learning model will have some way to receive some input, like this one, and it will have some way to generate some output. In this case, is this, or each one of these entities. And that's going to work even if you have, like, if you are doing machine learning over text, or if you are doing machine learning over audio, or images, or whatever, or numbers. So you have a machine learning model. Now what? Now we can make it a web API. Why would we want to do that? To show it to your colleagues, to integrate it with other internal apps, to deploy to production maybe directly. There are many reasons why you would want to make it a web API. That's what we are going to do next. But first, we're going to check the basics of a FastAPI app. So we just saw a similar app like this one a little bit ago. Now let's check this other. Example here. So we are declaring that we want an HTTP GET operation or an HTTP GET method, and we want it to go to this path /items/ and then we use this item ID. So when we deploy our application, let's say that we deploy it at this domain. When we go to /items and /5, this 5 is going to be interpreted as a path operation. So, sorry, as a path parameter. So this is going to be, this item ID is going to be a parameter, and this is going to be dynamic. And now we declare in the function how we want to receive it, and we want to receive it in this parameter item ID, and we are telling FastAPI that this item ID should be an integer. Again, this is the standard way to declare that this variable is of type integer. This is a standard in Python. But then FastAPI uses it additionally to what you will get normally, which is type checks and autocompletion. FastAPI uses this information to validate the data and to make sure that we actually receive an integer. So if we pass something different here, instead of a 5, we pass some text, then FastAPI will generate an error for the client automatically. So we are getting this item ID. FastAPI is detecting that it comes from the path, so it's extracting it from here. And now we're also declaring this other parameter here, which is Q, that is of type string, and by default is none. So this is an optional parameter, and because it's not part of the path, FastAPI will know that it has to extract this Q parameter from the query, which is this part, the part that goes after the question mark. So we are saying that Q equals some query. In this case, it means that this text some query will be the value of this parameter Q. In this specific, if we call the URL exactly like this. And then we can just use the data internally. So this is how it works. We just simply declare the parameters with the type annotations in the function, and then FastAPI extracts the data from the request. Now, the cool thing is that if we go to the same domain that we deployed our application and we go to /docs, we're going to get this user interface for free. That does the automatic documentation of our API. So in here, we have that this is a get HTTP operation that goes to the root path or the top level path, which is the first one that we created. And we have the new one that we just created, which is also another get operation that goes to /items/ and then item ID. And this item ID is a path parameter. Because it's a path parameter, we can also see that is declared here, that item ID is a path parameter that is an integer and that it is required. But then in this interface, we can also, well, first we write some basic code and then FastAPI makes a user documentation for you, which is nice. Let's now create a body. Let's now declare that we want to receive a JSON body in the request. So now what we are going to do is FastAPI is based on Pydantic. So we are going to, from Pydantic, we're going to import base model, and we're going to use this base model to create a class. That is this one, a class article that inherits from base model. And this class, if you have seen data classes, which are new in Python 3.7, this is very similar to that. If not, then you are just learning how it works now. And we are declaring here that we want to receive something that is called, that has a name content and is a string. And then we're saying that comments will be a list of strings. If you see this list comes from here, we are importing it from typing, we import the list. This is part of standard Python, and this is the standard way to declare that something is a list of some type. In this case, we are saying that comments is a list of strings, and by default, it's just an empty list. Now, what we do is that first we declare that this is a post HTTP operation, and we are going to receive something at /article/. And we are going to declare the parameter here in the function as article. This parameter article will be of type of an instance of this class article. This is, again, the standard way in Python to declare that this parameter will be an instance of this specific class. And then FastAPI will make sure that we receive an actual instance of this class, and we will be able to use that here inside in our code. So we can call article.content, and we will extract the content that we received in JSON as we declared it here. Now, let's actually see how that looks like in the automatic user documentation. So if we go again to that, the automatically generated documentation for the API, and we go and check it, we can see that now this is declared as a post HTTP operation, and that we receive this shape of data. That is what we declared. This is the shape of the data or the schema. And we can see that this is the equivalent of a Python dictionary or a JSON object that has a content that we declared, that is a string. And we have comments, which is a list of strings, or a JSON array of strings, which is a JSON array is the JSON term for a Python list. So yeah. And now we can actually interact with this user interface. It's not only for documentation, we can interact with the server right there from the browser. We can send a request. For example, here we're sending some content with some comments, and if we execute it, we get the message back live from our server. So we can interact directly with the server during development, or later we can use this interface to communicate with the API that we are creating. So we already made an API with a request that takes a body. Now let's combine that and let's receive a body and a query parameter. How does that look like? It's just the same thing. We declare one parameter, which is of type of this instance of this class article. So this will be an instance of this class article, which we created here. because it's one of these things based on the base model from Pydantic. FastAPI will recognize that it has to extract it from the body of the request, from JSON, and then we just declare another parameter. For example, in this case, it's big model, which will be a Boolean that by default is false. So to declare that we want to get a query parameter, we just add another parameter to our function. And now let's go and check the docs. And we can see that now this is how we will call the URL. It will be /article/ and then we will pass the question mark, and then we will pass the query parameter name, big model, and then equals, and then the value, which will be true. And we can see that the documentation is automatically updated to have that information. So big model is a query parameter, which is a Boolean that goes in the query. And because it's a Boolean, because we declare it as a Boolean, then the user interface detects that and knows that the only possible values are true and false. So it can like automatically update and generate the documentation accordingly for that. So we don't have to put everything in the body. We can use query parameters when they make sense. Now, let's actually combine those two ideas that we have been exploring, the FastAPI part and the machine learning part. There's actually no special magic. There's nothing particularly sophisticated about it. You can just import the Python parts and combine them with FastAPI. You don't have to do anything special for it to work. You don't have to include your machine learning model in some part of FastAPI or something like that. No, you can just import what you need. So in this case, we're just importing Spacie. We are loading the model here. So you can see that this is the model that we had before. This is independent of FastAPI, and then we create the FastAPI app. And then we are just using that model that we loaded. And we are using it to extract and to analyze the information from the content that we received in the article. And then we extract it. This is the result. Then we just extract each one of the entities, and then we are going to include that in the response. And then we just send in the message back with all the entities that we detected, and we're just checking if we use this parameter big model here or not. But you can see that we can just use the code directly that we will expect to use. And because FastAPI is making sure that we receive the data that we declared that we wanted to receive a JSON with a content and with a list of comments. FastAPI will make sure that we receive that, so we can just use that and call it directly and pass that to our model, to our machine learning model. And if we go to the docs, if we call and we execute another request using this automatic user interface, we will get the response back. And you can see that the response is generating the machine learning prediction that we were expecting. And we can do that live while we are developing it, or when it's deployed to production. Now, let's say that we want to receive something more complex than this simple article that we declared. We want to receive a JSON array of objects, of JSON objects in the body. So this will be the equivalent of a list. A JSON array is the equivalent of a Python list, and JSON objects are the equivalent of Python dictionaries. So let's say that we want to receive a list of this particular type of data. We just do, again, the same standard syntax for declaring the types of parameters and variables in Python. So we are just saying that now we're going to receive articles, and articles is going to be a list. And remember that this list is the same one that is here, that comes directly from typing. So this is the standard way to declare a list in Python. So we are saying that articles is a list of instances of this class article. And FastAPI will make sure that we receive that exact data shape in our parameter. And then because we received, because FastAPI is making sure that we are receiving this as a list, then we can iterate in this list. And then we can, for each one of the articles, we can check for each one of the comments, and then we can do all the processing that we were doing before, but now we are doing it for multiple articles at the same time. And if we go and check the user interface, the automatic API documentation user interface, we can see that now it is updated to receive, like the example value that we get here is now a list or a JSON array, because it has these square brackets, of objects, JSON objects with this data shape. So that just works. And using that, we can declare any type or any complex data shapes that can be like deeply nested with very different contents, and FastAPI will make sure that we receive exactly what we declared. Now let's see what happens. How is it that FastAPI makes sure that we receive the data that we declared? What happens if we send invalid data? So this is actually valid JSON. So this is not an incorrect syntax for JSON, but this is not what we declared that we were going to receive. Let's see how it is. So this is a JSON array, the equivalent of a list, so that's fine. The first one is a dictionary or a JSON object, that's fine. It has a content, which is a string, that's fine. And it has a comments, which is a list of strings. That's what we declared, so this part is valid. Now let's check this one. This has a content, which is a string. This is valid. And this doesn't have comments, but we declared that comments had a default value of an empty list, so comments are optional. They are not required, so this one is also valid with the way that we declared the body, or like the pedantic model, the way that we declare the data shape that we were going to receive. But now let's check this one. This has a text, which is a string, but this doesn't have the content that we declared that we were going to receive. We are expecting a key called content, but this one is called text. So this one doesn't have the required content key. And now let's check this one. This one here has a content, which is a string, so this is fine. This is working perfectly. But then the comments are a list, which is up to now, a list is fine. The first one is a string, that's fine. But the second one, this is not a string. And we were expecting a string. This is an object that contains another thing inside. So this one is invalid. Now let's try to send this data to the application, and we receive an automatic data validation error back that shows very clearly to the client, to whoever is using the API, where are the errors. So we can see that the location is in the body, inside of the articles, the item with index 2, so the third item, the content was a field required, and it's missing because we sent something called text instead of the content. And then we have another error that is, again, in the articles, in the index 3, inside of the index 3, in the comments, in the index 1, so the second item. The first is the index 0, so this is the index 1, this is the second item, that a string type was expected, and we actually sent a JSON object or a dictionary. So FastAPI is using those type annotations to, on one side, on one side, just by using type annotations, we get autocompletion and type checks. But on the other side, FastAPI is doing data conversion, because when we execute the code that is running this, we get the data shapes that we declared. But it's also doing data validation with that, and the client is getting a very clear error response when the data is invalid. So without valid data, FastAPI will protect our code from running with invalid data that will make our server explode. But with valid data, our code can be very happy and run without any problem. And because we are using standard type annotations, we get autocompletion in the editor for everything. So check this out. These articles is declared to be a list. So then in here inside of the code, we can iterate for article in articles, because this is indeed a list. And then because each one of these articles is going to be an instance of this article, we know that each article has comments, which is also a list. So we can iterate for comment in article.comments. But then, because we declared that comments is a list of strings, the editor is going to be able to know that each comment is of type string. So when we trigger autocompletion for each one of these comments, for each comment, then the editor is going to be able to know that it can provide completion for a string, and it's going to provide completion for the exact data type that we declared. And notice that we are in a double nested for loop, and still the editor is able to provide us with all this completion. This is because we are using standard Python type annotations. And we also get type checks. So because the editor knows that comment is specifically a string, the editor is going to know that we cannot sum a string with an integer. This is not a valid operation. We will have to convert this thing to a string or convert this thing to an integer. So we can detect a lot of bugs and a lot of errors right here in the editor while we are writing the code, instead of having to wait until we finish to write all the code and try to run it to see that there was a problem. So we can just detect a lot of these issues right away. And this is because it's all based on standard Python types. Now, FastAPI, you can get a lot of performance from FastAPI. This is a third-party benchmark. This is provided by Tech Empower. They run benchmarks on a lot of languages and a lot of frameworks and a lot of combinations of tools. And here we are just seeing the ones for Python, which are the blue lines, and the ones for Go, the programming language, Golang, which are the green lines. Go is a compiled language, so it should be faster than most of the other languages around. But with FastAPI, because it's based on Starlet, we can get a lot of performance, and we can get even better performance than with some of the Go language frameworks. So this is quite nice. This is quite good. We can get a lot of benefits from that without sacrificing, like, leaving Python. Now, you can see that there's a bunch here. Which one is the fastest is not necessarily that relevant. You can see that the numbers are quite close. In fact, Unicorn is the server. It's just the program that executes FastAPI. So Unicorn is actually faster than anything here because everything is running with Unicorn. But the point here is that you get on the ballpark of some of the best performance that you can get with Python. And you get all the data validation, data documentation, serialization, all that stuff. And as you can see, this has been able to handle more than 15,000 requests per second. So this is over 9,000 requests, which is quite good. Now, some other extra features. FastAPI has a very simple but quite powerful dependency injection system. It can be used to do, for example, authentication or handling database connections or things like that. It can be used to extend FastAPI in many ways without requiring any plugins. Like in most of the cases, you don't really require any type of plugin to work with FastAPI. You can use most of the things with just the dependency injection system. There are security tools to integrate with OAuth 2, including OAuth 2 scopes. OAuth 2 is the technology used by things like authentication with Google, GitHub, Facebook, and a bunch of others. And you can use those as the authentication for your system, or you can build a system that can work as an authentication provider like those. Because FastAPI underneath is an async framework, there's support for WebSockets, and there's also, of course, support for files, uploading or downloading files, or all that stuff. And there are integrated lightweight background tasks. So for things like saving a bunch of extra records after sending the response, or for sending, for example, an email notification after sending the response, these background tasks can be very helpful. There's easy GraphQL integration, and there's a bunch of extras that you can get with FastAPI. Of course, Jinja templates and things that you might be used to if you are building like a whole system, the whole HTML, for example, in a front end. With the backend, you can also do all that. But there's a bunch of other features that you can check in the documentation. Thank you very much. That's what I have for you. I guess we can check if there are some questions. Also, make sure you check the documentation at this address, and you can, of course, find me on GitHub, LinkedIn, and Twitter. But if you're interested, check the documentation here. I guess we can check if there are any questions.
Yeah, actually, I do have a question. I missed this presentation, I think half of the part. So, are you guys going to provide us the recording of this presentation also?
I think so. I don't control it because this is handled by the Data Science East Africa group directly. But I suspect so because I see a recording button on the corner, so I think so.
Okay, and one more question. Django has a ORM, object relational mapping, which helps in selecting the type, which is really great for selecting, even making SQL query. So do we have something like similar in FastAPI?
Yeah, so FastAPI is not dependent, it's not tightly coupled with any type of database, but you can integrate it with any type of database you want. You can use, for example, if you are using SQL relational databases, you can try with SQL Alchemy, which is like the most popular probably. I can see some recommendations of Tortoise too, which has been having support for async for longer. There's support for Geno, there's support for like many of these ORM independent libraries. Many of those, they even have documentation for how to use it with FastAPI, but there's normally no special trick. It's just like normally just using the dependency injection system, and then you can just use any type of database you want, including NoSQL systems like MongoDB and many others, Elasticsearch, whatever you want. So yeah, there's support for that.
Okay, thank you very much. Yeah.
Cool.
I have a one question. Thank you for first of all, thank you for a great presentation. Well, so I wanted to let's say I wanted to deploy an application with FastAPI, right? So it would handle 1,000 of requests in a second. So is there any configuration of Ubicorn and the Flask API? So FastAPI, sorry. So we need to do that so that we can make our application scalable and it wouldn't any without any, you can say, without any extra configuration.
Yeah, so there's an official Docker image for FastAPI that can do a lot of that for you, that has integrated Ubicorn with Unicorn and automatically starts the number of processes that it starts. It depends on the CPU that it's running on. So you can just start a single Docker container with that, and that will take care of like optimizing the performance in that machine for you. But if, for example, if you have like a big cluster, a Kubernetes cluster or something, then you can just probably use a single Ubicorn worker and then spawn multiple containers with that. But yeah, like with the default configurations or on the default official base image, you will probably be able to have like quite a good performance until you end up having to fine-tune the configurations specifically for your application. Okay. You can also check a lot. There's a lot of documentation in the FastAPI documentation about deploying specifically, so you can check a lot of the extra options there. I see that there was a question here on the chat. What about type hinting with the new Python 3.10? I think this is about a recent tweet asking that we were asking for people to show the support for this type of uses with type annotations. So here's the thing. FastAPI uses the type annotations not only to provide like the default things, which are autocompletion and type checks. FastAPI uses those same type annotations via Pydantic to do data validation, data serialization, and data documentation. That's why we get this nice user interface automatically. The thing is that they have been working a lot on improving this type annotations in Python itself. And one of the features that they were working on will make it a little bit more difficult to use these type annotations for these additional features. A little bit more difficult is just that you will have to declare those Pydantic models outside of functions. That was the main change that the code would have. Nevertheless, because we wanted to be able to, and they have been working on that for a long time, but like we didn't see the problem on time. But because we wanted to be able to have support for all
What
the
about
possible.
some?
Sorry.
What about some projects? Yeah, what about some
Oh
projects
wait.
running on microservice?
Let me finish the response to their question. So
Okay.
because we wanted to support like all the other use cases of these type annotations, then we were asking to delay that change that they were adding to Python to better figure out what is the best way to handle these use cases and probably improve the way Python works internally so that we can serve like most of the use cases properly. And the Python Steering Council decided to delay that and revert that decision to be able to support all the Pydantic and FastAPI community, which is like a great commitment from their side to support like the whole community and all these use cases. So in the end, about type hints with Python 3.10, there's no deal, there's nothing with that. It just works. It will just work fine, and we will figure out the best way to accommodate all the use cases that, from the ones that benefit from the new feature and from us for the next versions. Now, I think Arnold I don't know how to pronounce it. I'm sorry. Had raised their hand. Maybe you can ask first, and then we continue to the next question.
No, I don't have any question.
Okay.
Yeah, the question is like.
Yeah, Rajaram.
Yes, some existing frameworks like Spring Boot having microservice things, existing application is running. So how our FastAPI would be, since we are running on Spring Boot and microservices. So if we are planning to migrate to FastAPI, so how it apt or how we can go?
And I think that the sound is cutting a little bit, but I understand that. Like, how can you migrate from other frameworks to FastAPI, right?
Yeah, yes, microservices, Spring Boot to FastAPI.
Okay, Spring Boot is a Java framework, right? Well, in general.
Yes, yes, right.
Okay, perfect. In any from any framework actually to migrate to FastAPI, the first thing is that it's not necessarily that all the cases have to change and switch and migrate to FastAPI. There are many applications that are perfectly working and that there's no need to migrate them if they don't need like the benefits of FastAPI or they don't need to implement new features or things like that. But if you see that you will have benefits from FastAPI, the way that I will handle one of those migrations is to go step by step, not trying to migrate everything at the same time, but probably putting a front-end proxy like traffic on top to send some of the requests to some paths to the previous implementation, and then some of the requests with the new paths, with the new version, let's say, to the application built with FastAPI. And then you can separate it. And if you're already using microservices, then it's going to be a lot easier because you can just migrate each microservice independently. You will probably have to deal with all the complexities of microservices themselves, but you are probably already doing that. So just migrating each one in turn will probably be quite simple. And because FastAPI is based on these standards, on OpenAPI, you can generate clients for an application built with FastAPI automatically for almost any language, because this is an open standard. So there are many tools to generate clients for these other languages. I see there was a question here, how FastAPI handles requests other than JSON, say images. There are tools to receive files and to read the files and their contents. And you can also always receive the request directly and even parse it. Even if it's a strange custom data format, you will be able to extract that and read it directly. It's just that it has a very nice integrated support for JSON because there's this OpenAPI standard that can plug in with all that stuff, but you can read like any type of content that you can receive. Thank you for everyone that is saying that they support me. Thank you. I'm glad that you are liking FastAPI. What are the limitations of FastAPI? I don't know. What will be the limitations? I'm not sure. Like, for example, I wouldn't use FastAPI to create a front end, like a static website. For that, I will use something like Next.js, and I wouldn't even build a backend for that if it's mostly static content. What else? Like, I don't know. If you are, for example, if you are using, I don't really know which case would be better not using FastAPI. Maybe, for example, if you already have an application that is working and doesn't have any problems, then there's no need to migrate. But the limitations, I'm not sure what will be like a very specific limitation. I guess it will depend on the context. There are probably tons of limitations and tons of use cases that it will be better to build something in a different way because FastAPI wouldn't solve every use case. For example, if you are building I don't know, like a desktop application that doesn't have any type of server, then like it would make sense to do something with FastAPI. But yeah, I think it's made to serve. It was designed to work specifically well with APIs, with web APIs. But I have seen a lot of people using it for very different things, and it's that's amazing. Cool. There's another question here. What is the best file structure to structure my FastAPI project? I want to use only a single file. Does it have file structure like Django and Flask? Yes, of course. You can check on the documentation. There's a whole section about how to structure FastAPI and how to subdivide in different files. And there's a whole thing to have like subdivisions of your whole application, which are API routers. So you can have like a whole section, for example, for users, which lives in one file, and another one for items that lives in another file, and things like that. Great. I don't know if we have any more questions. Okay. Thank you very much. The session recording, I don't handle that part, but I imagine that the data science East Africa group will handle it later.
Thank you, Sebastian.
Thank you.
Thank you. Bye.
Bye.
Thank you so much. Bye.
Thank you for joining.
Okay, so thank you everyone. You can still hang out here. If you have a question for Sebastian, you can ask him. but I think the meeting is over. But you can still hang around for maybe a few minutes. It was a very powerful and interesting session. We really enjoyed, and we will be sharing the recorded version on YouTube. Yeah, you can visit Data Science East Africa YouTube. Also, we are inviting everyone who is interested in joining Data Fest, which is organized by Data Science East Africa. So thank you everyone. The session is over. You can leave or maybe remain and interact with your peers. Thank you. And thank you, Sebastian. It was a very informative session. We really enjoyed.
Thank you. Thank you very much. Thank you for the invitation. Goodbye, everyone. Have a good day. Bye.
Goodbye, Sebastian.